Questions 1 through 10 on the 2003 Grade 10 AMC 10B. Which of the following is the same as this expression? So let's write it out. We got 2 minus 4 plus 6 minus 8 plus 10 minus 12 and plus 14 on the numerator. The denominator is 3 minus 6, 9 minus 12, 15 minus 18, and plus 21. So this looks like negative 2 plus negative 2 plus negative 2 plus 14. Bottom looks like negative 3 minus 3 minus 3 plus 21. So we got 14 minus 6 on the top and 21 minus 9 on the bottom. So this is 8 over 12, and that reduces to 2 over 3. So number 1, the answer is C. Al gets the disease algebritis and must take 1 green pill, 1 pink pill each day for 2 weeks. A green pill costs $1 more than a pink pill, and Al's pills cost a total of $546 for the 2 weeks. How much does 1 green pill cost? So he has to take 1 pill every day for 2 weeks. So he has to take 14 green pills and 14 pink pills. They also tell you that the green pill costs $1 more than the pink pill. So G equals P plus 1. And then they also tell you that the total number of pills costs $546. So we have ample information to figure out the value of G, green pill. So the first thing I'm going to do is, instead of having this P here, I'm going to substitute for P in terms of G. So from that equation, P would be G minus 1. Correct? So now let's expand this. We have 14G plus 14G minus 14 is equal to 546. 28G is equal to 546 plus 14, which is 560. And therefore G is equal to 560 over 28. And therefore G is equal to 20. So $20 for 1 green pill. So number 2 is D. The sum of 5 consecutive even integers is 4 less than the sum of the first 8 consecutive odd numbers. What is the smallest number? What is the smallest of the even integers? So we have 5 consecutive even integers. So that means you have 2k plus 2, 2k plus 4, and 2k plus 6, and 2k plus 8. These are 5 consecutive even integers. And they're saying that this is 4 less than the sum of the first 8 consecutive odd numbers. So those are 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. And we've got to add a 4 in here because that's 4 less. So this is just basic math, adding them all up. 1, 2, 3, 4, 5, that's 10k. And then 2, 4, 6, 8, that looks like it's going to total 24. As long as I don't forget the final 4 there. And then this on this side is 64. So that means 10k is equal to 40 and k is equal to 4. Now they want the smallest of the even integers. The smallest of those even integers is this guy right here, 2k. So that means 2k would be 8. And therefore number 3, the answer is B. Rose fills each of the rectangular regions of her rectangular flower bed with a different type of flower. The lengths in feet of the rectangular regions in her flower bed are shown in the figure. She plants 1 flower per square foot in each region. Asters cost $1, begonias $1.50, cannas $2, dahlias, $2.50, and Easter lilies, $3. What is the least possible cost in dollars for her garden? So the first thing we need to do is figure out the areas of all these regions. So the first region, you can just label them A, B, C, D, and E. All right. So the areas, if we write areas here, A, B, C, D, and E as the regions. Area A is 4 times 5 is the area, so that's 20. B is 3 times 7, 21. C is 3 times 5, 15. D is 1 times 6, which is 6. And E, we have to figure out what the dimensions are. Well, that's 5 and that's 7, so this has to be 2. That's 3 and that's 1, so this has to be 2. So it's a 2 by 2 square, so the area is 4. Now, we want the least possible cost of this garden, and you do that by putting the most expensive flowers in the smallest region. So that means that we are going to do the following. We have to put the Easter lilies in the smallest region. So that means those guys will go here, $3. And then the next one, same thing. We have to minimize our costs, so we put the most expensive stuff in the larger, in the smaller regions. The next one is the $2.50 flowers. We'll put those here. And then we'll put the $2 ones here, $1.50 here, and then the cheapest one we'll put in the largest, like that. And then we have to just multiply to calculate the costs. So this looks like $30, $21, $30, $15, and $12. So the total cost, if you add up all these, is $108 for this garden. And therefore the answer would be A, 4A. Mo uses a mower to cut his rectangular 90-foot by 100-foot lawn. The swath he cuts is 28 inches wide, but he overlaps each cut by 4 inches to make sure that no grass is missed. He walks at a rate of 5,000 feet per hour while pushing the mower. Which of the following is closest to the number of hours it will take Mo to mow his lawn? So you've got this rectangular region, and it is in dimensions 150 feet, but they're talking in inches for that section that he cut, so I'm going to convert this to inches. So 1800 inches. And then the other dimension is 90 feet, and very similarly I'm going to convert that to inches, so that would be 1080 inches. And then the way he cuts it is a bit interesting. He's not cutting it exactly like down the row and then move over to the next row. He's doing a little bit of an overlap right here. So let me show you what that means. So he cuts his first row, whatever you want to call it. And they call it a swath, I think. I don't even know what a swath means. And then when he cuts the next one, right? I'll draw a different color. He doesn't just go like that. He overlaps. So what he's doing is slightly a little bit too like that. You see what I see? Like that. There we go. A little bit of an overlap. And then similarly another overlap here for the next row. Like that. Okay. So the very first time he cuts that swath, that row or whatever, it's 28 inches that he cuts. But the next time he cuts, it's not 28 inches, it's 24 inches. Why? Because 4 inches overlaps. You see what happens there? 4 inches of that has already been cut. So the only fresh new cut is the 24. And similarly, 24 on the next one and so on. So his total cuts in terms of inches are 28 for that first row, plus 24 for as many rows as he's cutting. And the number of rows, I don't know. It's n. And that total must equal this, 1,800. Correct? Because you got 28, then you got 24, 24, 24, and so on, all the way down that length. So this can easily be solved for n. And if you do, you get n is equal to about 73.83. So that means that he is making 73.83 of these rows, basically. Now, each time he makes a row, he's walking, correct? Now, how far is he walking for each row? I'm not talking about this length. I'm talking about this length. How far is he walking for each row? Well, he's walking 90 feet, correct? From here to here. So he's got 73.83 times that he walks down, and each time he walks 90 feet. So in total, 6,734.7 feet is how much walking he has to do to cut this entire lawn. Now they tell you that he walks at a rate of 5,000 feet per hour. So 6,034.7 feet divided by 5,000 feet per hour. That is going to give us our time. And this looks like 1.346 hours. That's how long it takes him to mow his lawn. So for number 5, the answer closest is C. Many television screens are rectangles that are measured by the length of their diagonals. The ratio of the horizontal length to the height in standard television is 4:3. The horizontal length of a 27-inch television screen is closest in inches to which of the following? So we've got a system here that you've got basically a rectangular screen, and most of the time when they sell TVs, they tell you the size of the screen is the diagonal. So a 27-inch screen, for example, is really just the diagonal that they're referring to. But what you want is to figure out the horizontal length. You say, well, I want to know the length from one end to the other on the horizontal. Well, no problem. They tell you the ratio is 4:3. So if this is 4x, this is 3x. And this is 3x, obviously. It's a rectangle. And you can just solve for x and figure out 4x. So use Pythagoras. 3x squared plus 4x squared is equal to 27 squared. So this looks like 9x squared plus 16x squared is equal to 729. And this is 25x squared is equal to 729. And therefore x squared is equal to 729 divided by 25. X is approximately 5.4. And therefore the horizontal, which is 4x, will be 4 times 5.4, which is 21.6. So closest number here is D for number 6. The symbolism x with those brackets denotes the largest integer not exceeding x. For example, 3 brackets is 3 and 9/2 brackets is 4. Compute that expression. So I hope you understand that if you have a number like 3.3 and then you put these brackets, it's the closest integer or the largest integer not exceeding that. So it would be 3. You're basically chopping off the decimals. All right. So this whole thing is basically 1 root plus 2 root plus 3 root, like that, all the way to 16. So I'll write that out first. So then what you do is you take the symbol of it, the brackets of it, basically like that. So let's see what we would get. Square root of 1 is 1, bracket will be 1. Square root of 2 is about 1.4, and if you take that bracket, it will be 1. Square root of 3 is 1.7. Chop off the decimal point, you get 1. Square root of 2, square root of 4 is 2. Square root of 5 is 2 point something, so that will be 2. Square root of 6, 2 point something, 2, 2, 2. And then finally you get to square root of 9 is 3. Again, 3 point something, 3 point something, 3 point something, and so on until you get to square root of 16, which is 4. So that's basically how this is done. And then the sum, of course, we got 3 of these 1s. We've got 1, 2, 3, 4, 5 of these 2s. And we got 1, 2, 3, 4, 5, 6, 7 of those 3s. And you've got a final 4 in there. So this is 3 plus 10 plus 21 plus 4. And that looks like 13 plus 25, which is 38. So number 7, the answer is B. The second and fourth terms of a geometric sequence are 2 and 6, which of the following is a possible first term? So in a geometric sequence, we have A, AR, AR squared, AR to the power of 3, and so on. So they tell you that the numerical value of the second term is 2, and the sixth term is 6. Or sorry, the fourth term is 6. And they want you to figure out what is the value of A. All right, no problem. So first let's take AR to the power of 3 divided by AR. This will give me 6 over 2. The A's cancel, and you're just left with R squared is equal to 3. So R is equal to plus or minus the square root of 3, like that. Now let's figure out A. AR is equal to 2. That's a given information. R we have as root 3. So therefore, A should be 2 over root 3, like that. And if you rationalize the denominator, which they often do, you'll get 2 root 3 over 3. And that is not one of the answer choices. Okay, no problem. I think it's because I got to choose this one there. So let's do that. Let's choose negative root 3 for R. Negative root 3, like that. So that means A is equal to 2 over negative root 3. And then if I rationalize the denominator, multiply top and bottom by root 3, like that, this will be 2 root 3 over 3, and there's a negative out front. And negative 2 root 3 over 3 is an answer, which is B. Find the value of x that satisfies this equation. Okay, so we have 25 negative 2, 5 to the power of 48 over x, and 5 to the power of 26 over x times 25 to the power of 17 over x. So I want to get the same base for everything, so I'm going to convert everything to 5s. So this will be 5 squared, negative 2. This is already in the base 5, so that's fine. And so is this one, 26 over x. And then this one will be 5 squared, 17 over x, like that. All right, so here we go. This one right here, you will multiply, so that will become 5 to the negative 4. The top, at this point, I'll just leave alone here, 48 over x. Sorry, that was an x there. And then 526 over x, and then this becomes 534 over x, because you're going to multiply that 2 times 17. So we have 548 over x. And then this one you will add these, so 26 over x plus 34 over x. So that's good because the denominator is the same, so that becomes 60 over x. And this is still 5 to the negative 4. And then now this guy here, you will subtract the exponents, so it'll be 48 over x minus 60 over x, like that. 5 to the negative 4. So 5 to the negative 4 Looks like 5 to the negative 12 over x. All right. Bases are the same, so that means these exponents have to be the same. So negative 4 is equal to negative 12 over x. That means x is equal to negative 12 over negative 4. X is therefore equal to 3. So number 9, the answer is B. Nebraska, the home of the American Mathematics Competition, changed its license plate scheme. Each old license plate consisted of a letter followed by 4 digits. Each new license plate consists of 3 letters followed by 3 digits. By how many times is the number of license plates increased? Possible license plates. So their old system or previous system, you had a letter with 4 numbers. So for example, N, 1, 2, 3, 4. So the number of possibilities for the N for the letter is 26 letters in the alphabet. And then for the number, for each digit, you got what? 10 possibilities, right? 0 through 9. So now you just multiply like that. So that looks like 26 times 10 to the power of 4. Old system. New system, they've got 3 letters and 3 numbers. Correct. So something like AMC 1, 2, 3. Now we need to figure out the number of possibilities. Well, for the letters, each of those have 26 different possibilities, correct? And for the digits, it's 10 for each. So this is now our new number, and I'm assuming this is a larger number. So 26 to the power of 3 times 10 to the power of 3. So by how many times is the number of possible license plates increased? So we have to now compare this to this. So we got to divide 26 cubed times 10 to the power of 3, 26 times 10 to the power of 4. And let's see here, the 26, one of them cancels, and from the 10, 1 cancels. So this is all that's left. 26 squared over 10, and that makes number 10, choice C.